Hello, welcome to another interesting mathematics class. My name is AK Omoji, your mathematics friend and tutor. Today we shall be talking about quadratic equation part 2. And before we go deep, please let's look at the objectives for this class. By the end of this class, you should be able to solve problems involving factorization of quadratic expressions and equations using the analytical method. In our previous lesson, we discussed how to apply the common factor method of the factorization method. And in this lesson, we shall be discussing the application of the analytical method. The analytical method actually builds on the common factor method. They are almost the same, just that the analytical method involves more steps and can solve more powerful problems than the initial common factor method. Now let's go deeper into how this analytical method is applied. Using the analytical method, we shall be solving the following problems. Example 1, factorize the expression 6x squared plus 5x minus 6. Example 2, what are the solutions to 2x squared plus 7x minus 4 equal to 0? Example 3, what are the zeros of x squared plus x minus 2 equal to 0? Notice the different terms used here. We use factorize, solutions, and zeros. These are different ways of saying the same thing, so don't get confused when you hear any of them. Now let's go through the steps involved in solving factorization problems using the analytical method. Let us say that we are given this equation: ax squared plus bx plus c is equal to 0. And we are expected to apply the analytical method to solve it. The first thing we need to do is to multiply a by c, that's a times c, which will give us ac. What is actually this a? The a is what you see here, which is called the coefficient of x squared, while the b is what you can see here, called the coefficient of x, and c is called the constant. Our next step will be to find two numbers that when multiplied will give us ac and when added will give us b. Let's call these two numbers f1 and f2. The f1 here would stand for factor 1, while the f2 will stand for factor 2. We are saying that we are looking for two factors, f1 and f2, that when we multiply we'll get ac. So if we multiply f1 by f2, we should have AC. Also, if we sum F1 plus F2, we should get B. How do we actually find these factors? Before we go ahead to find these factors, first of all, let's understand what a factor is and how we find them. What is actually a factor? A factor of a number is simply a number that divides that number without a remainder. I've repeated the term number, right? Don't get confused. We'll look at it now. How do we find the factors? We look for a number that divides the other given number without a remainder. For example, what are the factors of 100? Or we would say, what are the numbers that can divide 100 without a remainder? Let's start. 100 divided by 1 would give us what? 100, right? And also, 100 divided by 100 would give us what? 1, right? So we can now say that 1 is a factor of 100, while 100 is also a factor of itself. Let's try 2. 100 divided by 2 would give us what? 50, right? What if we divide 100 by 50? What do we get? We get 2. That means we can also say that 2 is a factor of 100 and also 50 is a factor of 100. Let's try 3. 100 divided by 3, what do you get? I have, in my own case, 33.33. Is that what you got? That means that 3 is not a factor of 100, neither is 33.33 a factor of 100. Let us try 4 now. 100 divided by 4 would give you what? 25. That's what I also have. That means now that 4 is a factor of 100 and also 25 is a factor of 100. Finally, let's try 5. 100 divided by 5 would give us what? 10. And also 100 divided by 10 will give us 5. That means that 5 is a factor of 100 and also 10 is a factor of 100. There are simple rules to find factors of any number, and the rules are this. 1. Every number is a factor of itself, just as we saw here that 100 is a factor of itself. Also, 1 is a factor of every number. As you can see, 100 divided by 1 still remains 100. Okay, so let's continue in our steps. We are now in step 3. Now that we have the factors, we replace b with these two factors, as shown here. b is now equal to f1 and f2. So we say b is equal to f1 plus f2. If we solve through, we can then say that bx is equal to f1 plus f2 all in bracket and then an x outside. The x simply means we can multiply everything inside this bracket with that x. When we do the multiplication, or which you simply call expansion, we would have f1 multiplied by x plus f2 multiplied by x, as shown in our equation 3. Step 4. We are rewriting the equation as shown below. Actually, what we are now doing is to replace b, as seen here, with f1x plus f2x. So, by substituting f1x plus f2x in place of b, we now have ax squared plus f1x as the part we are calling the left part. Here is referred to as part A. Please note, this f1x is the same thing as this f1x here. Then again, we have f2x plus c in another bracket, which we will refer to as part B. Also note that this f2x is the same thing as this f2x here. And both of them are equal to 0. Let's call this equation equation 4. Next will be our step 5. From the equation 4 we got earlier, we are to check for common factors of part A and part B, respectively. If you look at the part A, which is this part now, ax squared plus f1x, we can find that they both have x in common, just as we did in the common factor method. They both have x. That means we can bring out the x, and then we bring out the x, we have x in front, then open a bracket and write ax plus f1, then we close the bracket. This will be referred to as our equation 5 now. We do the same thing for the second part, which is the part B. Our part B is f2x plus c. Actually, the only thing we have in common here is 1. So that means we can bring out 1, though it seems invisible. There's a 1 here and another 1 here. If we bring out that 1, we now have 1 outside the bracket, then we open the bracket and write f2x plus c. That will be called our equation 6. Step 6. If we have done our work well, ax plus f1 would be equal to f2x plus c. Therefore, we can now write the equation as x, open a bracket, ax plus f1, we close that, plus 1, open a bracket and write f2x plus c is equal to 0. That is the final equation we are having. So we now say, by collecting the like terms, we would have now that x plus 1 in one bracket, and then we also have ax plus f1, both will be equal to 0. That is because at this point, ax plus f1 must be equal to f2x plus c if we did our factorization well. This process might look difficult, but by the time we apply it to solve problems, you understand how simple it is. So let's try to use them to solve problems. Let us start with example 1. Let's factorize the expression 6x squared plus 5x minus 6. Remember, this is an expression, not yet an equation. So the first thing we need to do here is to ensure we make it an equation by adding the equality sign and then a 0. Next thing we need to do is to pick out the things that were given to us. Normally we just write given. That is, from the equation or expression, the things we are about to state were given to us. That is why we just say given. We were given the coefficient of x squared to be 6 and the coefficient of x to be 5, while the constant was given to us as -6. So our first step is to equate the expression to 0 and identify that a is equal to 6, b is equal to 5, and then c is equal to -6. Please take note, the equating to 0 has been done already here. Step 2, get the value of AC, which is 6 times -6, and that will be equal to -36. Look at this. We said initially that our first step would be to get AC, which is by multiplying the value of A times the value of C. In this case, our A is 6, and then our C is -6. By multiplying both, we get the -36 that you can see. Now let's look for two factors of AC that when multiplied would give us -36, that is the value of AC, and when added will give us +5, that's the value of B. Look at the table beside and let's find the factors. If we look at the factors, we can say -1 is a factor of 36. That's to say, if we divide 36 by -1, we'll get -36, and that is the value of AC. So 36 divided by -1 would give us -36. This is the value of AC. We are correct. That means -1 is a factor of 36. And then we can find the AC as -36. But remember the next step, that we have to add these two factors. And when we add them, they should give us a value in B. That is to say, when we add F1 and F2, we should get 5. Let's try to see if that worked. -1 plus 36 would give us what? It will give us 35. That didn't work, which means our B was not met. We keep repeating this process as we did earlier for the value of -2, -3, and -4. For me, I realized that -4 and 9 were the right factors for me to use now, because 9 plus -4 would give me 5. And that's why I choose that factor. Also, if you look down here, you see that 9 times -4 will still give me -36, and that is AC. We are still correct here. And when we add them, we would have that 9 plus -4 would give us 5. It means we now have our B. So let's go to our step 4, which will be to replace the value of B with the two factors F1 and F2. Our two factors are actually 9 and -4. So let's replace B with those two factors. Our B is equal to 5. So when we replace it, we'll have 9 and then -4 in place of 5. But remember, from this equation, there is x, which is the unknown or variable, attached to 5. That's why we have 5x. By replacing 5 with 9 minus 4, we now have this value in the bracket. And then we only add back the x, which is already in the left hand side. Remember, to keep our equation balanced, whatever we do to the left hand side, we'd also have to do that to the right hand side. Well, next thing we need to just do is expand this bracket here. To expand that bracket, we use the x outside to multiply everything inside that bracket. So we'd say x times 9 will give us 9x. Also, x times -4 will give us this -4x. We now have this equation in this form. 6x squared plus 9x minus 4x minus 6 is equal to 0. Please note that these two middle terms 9x and minus 4x are only replacing 5x. In our step 5, we now factor out common terms from the first two terms and the last two terms. The first two terms are 6x squared plus 9x, while the last two terms are minus 4x minus 6. They are all equal to 0. If we look at the first two terms, 6x squared and 9x, the common factor for both of them is 3x. That is because 3x can go into 6x squared and it will give us 2x. Also, 3x can go into 9x and it will give us 3. This handles our first part. Now, we are through with the first part. We look at the second part. The common factor for minus 4x and minus 6 is simply minus 2. So we take the common factor out, and that is this minus 2 you're seeing here. And then minus 4 divided by minus 2 would give us 2. And then the x still is there, so we have 2x. Minus 6 divided by minus 2 would give us 3. And that's why we have this plus 3 here. That also handles this part. Having finished with our fifth step, now let's go to the sixth step. Let's collect like terms now. By collecting like terms, we have 3x minus 2 and 2x plus 3, both equal to 0. Our seventh step is now to make x subject, or simply to get the roots from the factors. Remember, these are factors. So we want to get the root from them, or simply make x subject. We take the first one. 3x minus 2 is equal to 0. First thing to do is to move the minus 2 to the right hand side. Remember, whenever a sign crosses the equality sign, it changes. So if positive sign crosses the equality sign, it changes to negative, and if negative crosses, it changes to positive. This would cross the equality sign, and then it will change to positive. So we now have 3x is equal to 2. Then we divide both sides by 3. When we do that, the 3 here will cancel this 3, and we'll have x is now equal to 2 divided by 3, as you have here. Now, we will continue to have 2x plus 3 is equal to 0. As we did before, let us move plus 3 to the right hand side. Remember, because it's positive, when it crosses the equality sign, it's going to turn to negative. So we now have 2x plus 3 is equal to 0. Now when it crosses, we have 2x is equal to minus 3. Let's divide both sides by the coefficient of x, which is 2. We will now have this. The 2 will cancel out the 2, and we'll be left with x is equal to minus 3 over 2. And that's what we have here. So now that we are through with our first example, let us apply the same steps we applied initially to solve this example. What are the solutions to minus 4 plus 2x squared plus 7x equal to 0? The solution has just one initial step that we didn't add in our first part. Remember, in the other one, it was properly arranged. Now, we just need to rearrange. What we do is to now say, instead of having the minus 4 in front, we'll rearrange it to be 2x squared plus 7x minus 4 equal to 0. Every other thing remains the same as we did in other steps. As a hint, look at these things. Our AC would be equal to minus 8. That is 2 times minus 4. Our factor 1 and factor 2 are 8 and minus 1. So the equation will now become 2x squared plus 7x minus 4 equal to 2x squared plus 8x minus x minus 4. So we now have 2x, open your bracket, x plus 4 minus 1, open another bracket, x plus 4. You now see that the x plus 4 and the x plus 4 in both brackets are the same. So we go to the last stage, which is now 2x minus 1, this value is here, and x plus 4, any of them in the bracket. we make x subjects, and by doing that, we have 2x minus 1 equal to 0. That will now mean we have x is equal to 1 over 2. Next, we also have x plus 4 is equal to 0. Therefore, x is equal to minus 4. All we did was follow the same steps as we did before. Lastly, I would like you to try this out by yourself. And these are the hints. We are expected to solve for zeros of x squared plus x minus 2 and is equal to 0. Remember I said before, these terms used are almost the same. Factorize solutions to zeros of, they all mean the same thing. So what we are expected to do here is simply to factorize. So what are the hints you need to get? First of all, our a is equal to 1, our b is equal to 1, and our c is equal to minus 2. Therefore, our AC would be equal to minus 2. So you find two numbers that when you multiply them, you get minus 2, and when you add them, you get 1. If you do that, and if you follow the steps we followed earlier, you'll be able to get this. Did your answer correspond with mine? If they did, it means you've learned to solve factorization problems using the analytical method. Now, having done this, let's now summarize the things we've learned so far. We learned that the secret of solving a quadratic equation by factorization method lies in our ability to find the proper factors. We also learned that in the analytical method of factorizing, we have to find two factors whose product is AC and sum is B. Going on, we also learned that common numbers and latest factors are grouped together. Next, we then solve for the unknown variable, which could be x. Actually, in our case, it was basically x. Finally, we now know that roots are not exactly in the same form as factors. Example, x minus 3 and x plus 1 are factors of x squared minus 2x minus 3, which is equal to 0, while x equal to 3 and x equal to minus 1 are the roots or solutions of x squared minus 2x minus 3 equal to 0. Now that we've gone through this whole process and I've learned a lot of things, let us apply what we've learned in solving these simple questions. Question number 1. What are the solutions to x squared minus 5x plus 6 equal to 0? Take your time, go through it, let's see what you get. What's your answer? The answer is B, which is x equal to 3 and x equal to 2. Question number 2. The factors of 3x squared minus 11x plus 6 are? The answer is A, x minus 3 and 3x minus 2. Thank you for your time. I am sure that you can now solve quadratic equations using the factorization method and applying the analytical method. Till we meet next time, bye-bye.